Okay, in today's video, we're going to be talking about solving absolute value equations. As we do, keep in mind a absolute value function is a piecewise function defined as x if x is greater than or equal to 0, or negative x if x is less than 0. So that what that means when we solve an equation is that we will end up having to break it apart at some point along the process. So basically, once we get the absolute value bars apart, we will break it up. So if I look at example 1, find the zeros, or solutions, for the equation absolute value of 2x plus 3 equal to 4. In the video, we're going to skip the checking here. Actually, we might check it in just by plug and chug, but I don't have a calculator handy on the iPad. So for solving these equations, the first thing we want to do is make sure there's nothing outside the absolute value bars, and you can see that there's nothing on either side until after the equal sign. So that is where we want to start. Next, once everything from the outside of the bars is gone, we will break it up into two separate equations. First of all, the first one is 2x plus 3 is equal to positive 4. Because there's two numbers that when you take the absolute value of it, it will equal a positive 4. One of those numbers is positive 4 itself. The other number is if the inside of the bars, 2x plus 3, could also be negative 4 instead. That would also give the same result of the absolute value being a positive 4. So we break it apart like this, and now we just solve each equation individually. Subtract 3, 2x equals 1, divide by 2, x is equal to 1/2. And for the other one, again, subtract 3, so 2x equals negative 7, divide by 2, and we get the second answer is x equals negative 7/2. So those are the two answers for this equation. We can check them just by plugging it in. 2 times negative 7/2 plus 3. If we type this into the calculator or simplify it, as we'll cancel. Negative 7 plus 3 is negative 4. Absolute value of negative 4 is positive 4. So the first side checks out. And if we plug 1/2 in, let's just erase some of that. We plug 1/2 in. 1/2 2 times 2, again the 2's cancel out, leaving us with 1 plus 3, which is a positive 4. And absolute value of a positive 4 is indeed 4. So both answers do check out. The second problem we have here is a word problem. Example 2, yesterday's high and low temperatures each varied 12 degrees Fahrenheit from the average daily temperature of 61 degrees Fahrenheit. Write an absolute value equation to represent x, the high and low temperatures that day. Then solve the equation. Now, most absolute value equations will look like one of two things. They will have, obviously, absolute value bars. We'll have an equal sign. Usually, if it has varied within, that's a way of saying plus or minus 12 degrees Fahrenheit, which means it could be 12 degrees above or 12 degrees below the median or the average. Usually that varies within, or the word varied or within tells you that it's going to be by itself. Next, inside the bars, it's always going to be a minus sign. Or at least every absolute value word problem I've come across has been a minus sign. The rest of the setup will be either be the average minus a specific amount, or a specific amount minus the average. In this case, we know the average, so I'll subtract the average from some unknown, which will represent the high and the low. Now, the only difference to this setup that you might typically see in word problems is there might be a number beside the x. But other than that, I've not seen any other setups with absolute value word problems. Once we get it set up, though, we're going to solve it. So there's nothing outside the bars again, so I'm just going to get rid of the bars by breaking it apart into two separate equations. The first is x minus 61 is equal to a positive 12. The second is x minus 61 is equal to a negative 12. To solve this, we're just going to add 61 on both sides. So we get x is equal to 73, or x equals, I think that's 49. Yeah, 49. So basically this tells us a high of 73 or a low of 49. Now this last one, if we look at the last example on this page here, we're supposed to solve this equation, the absolute value of 3x plus 5, close the bars, equal to negative 7. We're told to check it with the Desmos calculator. So what's going to happen when we try to solve this is, if we go to break it apart, we could easily just break it apart if we don't stop and think. The way I break it apart is I stop and think about what numbers do you take the absolute value of to get the number on the right side, or the negative 7. Is there a number you can take the absolute value of and get negative 7? No, because when you take the absolute value stuff, it's always going to be positive. So there is no number that you can put on the other side of the equation that would satisfy it. Therefore, no solution. If we go ahead and graph this on Desmos, and I'm just going to sketch a graph, the equation will look something like, let's see, something like this. That will be the first line. The negative 7 will be down here. And you can see that they don't intersect, therefore there won't be any solutions. So you can graph that on Desmos to verify if you'd like. Okay, so I'm just going to talk about the different possibilities when solving absolute value equations. So there are three possibilities. You can have either 0, 1 solution, or 2 solutions for absolute value equations. Normally, 0 solutions occur when the absolute value bars are equal to a negative number. Since the absolute value of something can never equal a negative number, that's why we get no solutions. 1 solution occurs when we have the absolute value bars equal to 0. The way we've been breaking it apart is we take the inside stuff and we set it equal to positive the number on the other side, and we take the inside stuff and set it equal to negative the stuff on the other side. But positive and negative 0, they're the same thing. So you would get the same solution if you did that. And lastly, 2 solutions if we have the absolute value bars equal to a positive number. Those are the different options for solutions. Okay, example 4 is a little bit harder. Notice this time we have stuff outside the absolute value bars. So I often describe this as like a peanut shell. We can't get to our peanut, which is the stuff inside the bars, without getting rid of the shell. So we have to get rid of the stuff outside the bars first before we can break it apart. So the first thing I will do is reversal of operation. So I'll subtract 11. So I got negative 2, absolute value of x plus 5 is equal to negative 16? No, 26, sorry. Negative 26. And then again, I still have stuff outside, so I can't get to the stuff on the inside of the bars. So I'm going to divide both sides by negative 2. So we get absolute value bars of x plus 5 is equal to 13. Now if you look at the very beginning of the problem, you can see that it was originally equal to a negative number. But that doesn't matter because the absolute value bars weren't by themselves. Now if I stop right here, since the absolute value bars are by themselves, and I double check, it's equal to a positive number, which means we can break it apart into the two separate problems. So I'll break it up into the possibility that x plus 5 was equal to a positive 13, and the chance that x plus 5 equals a negative 13. And then I'll just finish off each of these equations. Subtract 5, subtract 5. Get x is equal to 8. If I subtract 5 on the other one, I get x is equal to negative 18. Those are my two answers for this equation. Now the last example you probably won't come across, but as you can see, it's another solving the equation, but this time there's a little bit of a difference. This time we also have an x on the other side of the equal sign. So, with that, I'm still going to kind of start it off the same way. I'm going to get rid of everything that's outside of the bars on the left side. So I'm going to subtract 8 on both sides. That's going to leave me with absolute value of x minus 2 is equal to 1 minus 2x. Now, normally when we did it before, we would break it up into x plus 5, in the case of the previous one, equal to a positive number, and x plus 5 equal to the negative number. We're going to still do that, but it's going to look a little bit different because I don't just have a number on the right side here. When I break it up, I'm still going to have x minus 2 equal to, well, for the positive version, it's simply going to be 1 minus 2x. But for the other version, it's going to be x minus 2 equals a negative 1 minus 2x. Basically, it's the same thing as what we've been doing. Just we have to put it in parentheses because there's two terms. After this, you just solve each equation like a linear equation. So I'm going to have to collect the like term. I'm going to start with the left side, the left equation. So I'm going to add 2x on both sides. That's going to give me 3x minus 2 equals 1. Add 2. 3x equals 3. And then divide by 3. So we get one possible answer is x equal to 3. For the other side, I'm going to have to distribute the negative through. Give me x minus 2 equals negative 1 plus 2x. Then I will again move the x's over, so I'll subtract 2x on both sides. Yeah, I guess I'll subtract the 2x. So get negative x minus 2 equals negative 1. Add 2. Negative x is equal to 1. And divide by negative 1. So x is equal to negative 1. So these are the two possible answers. Now with this problem, because there was an x on the outside of the absolute value bars as well, we need to actually check them. Usually if you stop and think back before you break it up, right there, as to whether the bars are equal to a positive or a negative number, you can usually avoid having to go and check them, though it's still a good idea. But because this had an x on the outside, we do have to go back and check. If I plug the 3 in, 3 minus 2, absolute value of that, plus 8, is that equal to 9 minus 2 times 3? That's 6. 9 minus 6 is 3. That's going to be 9, so that's definitely not equal. So plugging in 3 did not give me the same thing. If I plug in negative 1, I got negative 1 minus 2 in the bars, plus 8 equals 9 minus 2 times negative 1, which is going to make it plus 2. It's going to give me 11. And on the other side, I have negative 3, but absolute value makes it positive 3, plus 8 is 11, so 11 equals 11. So negative 1 appears to be the only solution for this problem. So do make sure you double check if you have an x on the outside of the bars.